Alright, we're going to take a look at some examples of multiplying rational expressions. First thing we're going to do is we're going to factor as much as we can. I'm going to start with the first rational expression, 9x minus 9 over 3x plus 6, and I'm going to factor its numerator. First of all, notice there is a GCF there, and that GCF, or greatest common factor, is 9. So when I multiply 9 times an x, I get the 9x. And when I multiply 9 times a negative 1, I get a negative 9. Therefore, the factors of my numerator are 9 times x minus 1. Now I'm going to factor the denominator, 3x plus 6. Again, that has a GCF, a greatest common factor, and that's a 3. So we're going to factor that out. When I multiply 3 times x, I get the 3x. And when I multiply 3 times 2, I get a 6. Therefore, the factors of my denominator are 3 and x plus 2. Then I'm going to come over to the other rational expression, x plus 2 over x minus 1. And I'm going to see if I can factor. X plus 2 cannot be factored, therefore I'm going to leave it as x plus 2. Now I'm going to the denominator, x minus 1. Same thing, there is no GCF. I can't factor it, so I'll leave it as x minus 1. So at this point, I've factored both my numerator and denominator in both of my rational expressions. Now what I'm going to do is come over and simplify or cross out some common factors. In this case, I'm going to cross out the x minus 1s, and I can also cross out x plus 2. These are common factors. So notice that I'm left with 9 over 3. Of course, 9 over 3 can also be reduced or simplified. When you divide 9 by 3, you're left with a 3. Therefore, when I multiply 9x minus 9 over 3x plus 6 times x plus 2 over x minus 1, I end up with 3. Alright, example number 2. We're going to multiply the two rational expressions. Just like I did with the first example, I'm going to factor the first rational expression, starting with the numerator x squared plus 2x plus 4. Notice the leading coefficient is a 1. Therefore, I'm looking for the factors of that trinomial. I know that when I multiply x times x, I get an x squared. Now I need some factors of 4 that are going to add up to 2. In other words, what two numbers can I multiply together to get 4 that are also going to add up to a 2? Well, in this case, you can see there are no factors. There are no numbers that I can multiply together to get 4, and they're also going to add up to 2. Therefore, this cannot be factored. Okay, so this is going to remain x squared plus 2x plus 4. If I go down to the denominator, x plus 3, that can't be factored either. There is no GCF. Can't factor x plus 3, so I'll leave it as x plus 3. Then I'm going over to the second rational expression, 2x plus 6 over x squared plus 2x plus 4. 2x plus 6 does have a greatest common factor, and it's a 2. So 2 times something will give me 2x plus 6. When I multiply 2 times x, I get the 2x. And when I multiply 2 times 3, I get a 6. Therefore, the factors are 2 times x plus 3. Now I'm going to go down to the denominator, x squared plus 2x plus 4. Notice I've already tried to factor that earlier. I found out I couldn't, so I'm going to leave it as x squared plus 2x plus 4. At this point, I've done all the factoring that I can. What I'm going to do now is go ahead and look for some factors I can cancel out. I can cancel out the x squared plus 2x plus 4. I can also cancel out the x plus 3's. So notice what I'm left with is a 2. Therefore, when I multiply these two rational expressions, the answer is 2. Alright, example number 3. This time we're multiplying the two rational expressions, x minus 9 over x plus 1 times x squared minus 1 over x plus 9. First thing I'm going to do is try and factor my numerator and denominator in the first rational expression. X minus 9 cannot be factored, so I'm going to leave it as x minus 9. X plus 1, again, cannot be factored, therefore I'm going to leave it as x plus 1. Now I'm going to go over to the second rational expression, x squared minus 1. That can be factored if we use our difference of squares. We know that the square root of x squared is x. We know that the square root of 1 is 1. Therefore, the two factors are x minus 1 and a x plus 1. Again, this method is the difference of squares. Now I'm going to go down to the denominator, x plus 9. That cannot be factored. There is no GCF, so I'll leave it as x plus 9. At this point, I've done all the factoring that I can. Now what I'm looking for is some common factors that I can cancel out. In this case, I can cancel out this x plus 1 with this x plus 1. Notice that I cannot cancel out x minus 9 and x plus 9. Those are not the same. Therefore, don't cancel those out. So what I'm left with is my numerator, x minus 9 and x minus 1. And for my denominator, I'm left with x plus 9. Therefore, I can leave the answer like this. Or I can take this one step further and actually use the FOIL method to multiply the two binomials on the top there. But at this point, we'll just go ahead and leave it as such. And this is our answer.